All right, today we've got the Unit 8 Objective 4 notes, solving for angles. So today we're going to start to use a little bit of algebra to work with the trig stuff we've been doing, and then use all the pieces that we've learned together to figure out what our answer is going to be for our angle. Okay, you'll see what I'm talking about in a minute. But first, like it says, you're going to need all the tools you've acquired so far in this unit, and what are those tools? Well, for a 30, 60, 90 right triangle, what are the sides of that right triangle? This is one of our special right triangles. Well, normally it's a, 2a, and a root 3. But if we stick in a as 1, then we get 1, 2, and root 3. Okay? Same thing for a 60, 30, 90 right triangle. It's just oriented a little bit differently. Now it's 1, 2, and root 3 there. And then if we have a 45, 45, 90 right triangle, we get 1, 1, and root 2. Okay, so filling out those values is something that you definitely need to know how to do. If you don't know how to do that, you're going to be stuck on a lot of problems. Okay, what else do we know? We got SOHCAHTOA. That's already written out for us, so that's good. That tells us the the ratios for sine, cosine, and tangent. Before we move on to the next part, what are the other ratios for sine, cosine, and tangent? Because what if we have a quadrantal, for example? Well, then I can't use SOHCAHTOA. I need to use the other definitions of sine, cosine, and tangent. So the sine of theta. How else can we define that? Now, if you don't remember, you don't have to memorize it. Just go look at a special right triangle or any triangle that's drawn for us. Normally, the opposite side over the hypotenuse is going to, opposite over hypotenuse is going to be sine. The opposite side, that's our y value. That's how far up or down we're going. And then the hypotenuse, well, that's going to be our radius in the unit circle. So it's y over r. Okay. What is cosine of our angle? Well, normally it's the adjacent side over the hypotenuse. And then again, if we drew one in the unit circle here, so you might want to use an axis to draw this. But the adjacent side is how far left and right we're going. So that's our x value. And then the hypotenuse is our radius. So x over r. And then if we have tangent of some angle, so the tangent of theta, well, how can we define the tangent of theta? Well, normally it's opposite over adjacent, which is the how far up or down we're going. That's our y value over our x value. So y over x. Okay. So if you ever forget these definitions of sine, cosine, and tangent, well, not a big deal. Just draw an axis and then draw a triangle. Okay, I would just draw in quadrant 1, keep it simple, and say, okay, normally my opposite side is my y's. I'm going to replace the o's, with y's. I'm going to replace the adjacent sides with x's. I'm going to replace the hypotenuse with the radius. Okay, so anyways, here are our definitions of sine, cosine, and tangent. Okay. Next, this blank axis. This is to help us remember where our trig functions are positive. Okay, so remember, all students take calculus, or maybe easier to remember and more relevant, all students text in class. Okay, but this tells us which trig functions are positive in which quadrants. Okay, and then with these pieces, we're going to be able to solve these equations down here for our missing variable, which is our angle in this case. Okay. All right, before we get to those problems, though, part 1, the easier part, indicate the possible quadrants in which the terminating ray for theta could lie. Okay, so then we just want to figure out which quadrants could this happen in. So they're saying the cosine of some angle is less than 0. That's how we want to read that. Okay, well, when does cosine of something come out less than 0? What's another way to say less than 0? Well, less than 0 would be a negative number. So when does cosine come out negative in which quadrants? Well, let's see, cosine comes out positive in quadrant 1 and quadrant 4, so then it's going to be negative in 2 and 3. So then this could be true in quadrant 2 or quadrant 3. So I'm going to put Q2 or Q3. All right, next. If I have the sine of some angle, when can that come out less than 0? In other words, when can sine come out negative when it's in what quadrants? Okay, so again, we want to look at our little cheat sheet up here. Well, I know sine is positive in quadrants 1 and 2. Remember, A is for all. All of my trig functions are positive in quadrant 1. And then sine is positive in quadrant 2, which means sine can come out less than 0. Sine can come out negative in quadrants 3 and 4. So we're going to put Q3 or Q4. And then this stuff will come into play on these problems down here as well. Okay, next, if I have tangent squared of theta, when can that come out less than 0? So again, I'm going to take tangent of theta and square it, and then when can that come out less than 0? Well, when I take anything and square it, it's going to be positive. So then when is this thing going to be less than 0? Well, never. That can't happen So this would be no solution if this came up in our equation. Okay, because again, after we square something, whether it starts off positive or negative, when I square it, it's going to be positive, so then something squared is never going to be less than 0. Okay, it could possibly equal 0, but that wasn't an option. Okay, and then the last part, if I take sine of something and square it, when is that going to come out greater than 0? In other words, when is this going to come out positive? Well, since I'm squaring it, it's always going to be positive, so then this would happen in all quadrants. Okay, so we need to be able to identify what quadrants certain things are going to happen in, because that's going to help us find our answer, as we'll see with these next 4 examples. Okay, all right, so part 2, this is the tougher part, solve for values of theta such that our answers are between 0 and 360 degrees. Okay, because again, if we say, oh, well, the answer is 30 degrees, well, then that could also be 390 degrees. Okay, for example, what I mean by that is we can list any coterminal angle. Well, we don't want to have a bunch of answers. We're going to say, okay, what's the 1 or maybe 2 or 3 or 4 answers that work? And we want them to be between 0 and 360. So we want to find all the answers between 0 and 360, not any extra coterminal angles. We don't care about those. Okay? All right, so then how do we solve this thing? The first thing we want to do, what are we trying to solve for? Well, we're trying to solve for theta, but do we want to get theta by itself? Well, not really. We have 2 times the sine of theta plus 1 equals 0. This is kind of like 2x plus 1 equals 0. And then how would we solve this thing? Well, we want to get x by itself. We'd start by subtracting 1 from both sides. And then we get 2x equals negative 1. And you don't need to write this part. And then divide by 2. And we get x equals negative 1/2. Okay, so if it's a basic algebra equation like this, we want to get x by itself. What do we want to get by itself in this problem, though? Because we're trying to solve for theta, but, after I subtract 1 and divide by 2, how do I get rid of sine? Can I divide by sine? Well, no, because, again, sine is an operation. It's not, a number that I could just get rid of. Okay? So anyways, here we want to get sine theta by itself. Here we want to get cosine theta by itself. Here we want to get tangent squared theta by itself. And then here, this one's a little bit different. We'll get to that at the end. Okay, so here, we don't want to just get the variable by itself. We don't want to get theta by itself. Let's zoom in a little bit. We want to get sine theta by itself. Okay, so we want to get the trig part by itself first. Okay, so how do I get the trig part by itself? Well, just like we did on that algebra equation, I want to subtract 1 from both sides of my equation. And then that gives us 2 times the sine of theta equals negative 1. And then next we want to divide both sides by 2. And then I get sine theta equals negative 1/2. Okay, great. Am I done? Well, not quite. Okay, but now we're closer. We know that the sine of some angle equals negative 1/2. Okay, well now we need to figure out a couple things. First of all, where does sine come out negative? So where am I going to find my answers? Well, again, if we look at our cheat sheet up here, sine is positive in quadrants 1 and 2. So then sine is going to be negative in quadrants 3 and 4. So then I know that my answers are going to lie in quadrants 3 and 4. So then we're a little bit closer there. And then next, well, the sine of what angle equals negative 1/2? Well, don't worry about the negative. We already know that means we're in quadrants 3 and 4. And then the sine of what angle is 1/2? And if we look at our special right triangles, let's see, is it the sine of 45? That'd be 1 over root 2. No, that's not right. How about 60 degrees? That'd be root 3 over 2. No, that's not right. How about 30 degrees? 1 over 2. Yeah, that's what we want. So then now we know that we have a 30-degree angle in quadrants 3 and 4, because, again, sine comes out negative in quadrants 3 and 4. And then the sine of what angle is 1/2? Well, that's 30 degrees. Okay? So then what are our answers going to be? Well, let's see. That means on my axis here, that means we need to rotate all the way to here to give us a 30-degree reference angle in quadrant 3, which, how far do we have to rotate to get there? So what's one of my answers for theta going to be? Well, this would be 180 degrees to get to here, and then 30 degrees past that, that'd be 210 degrees. So then one of my answers is 210 degrees. Okay, because again, that gives me a 30-degree reference angle in quadrant 3, which is where sine is negative. That's what we want. And then my other answer is going to be when I get a 30-degree reference angle in quadrant 4. Okay, so then how far around do I have to rotate to get a 30-degree reference angle in quadrant 4? So if this angle is 30 degrees, let's see, a full rotation would be 360 degrees, and then minus 30 degrees gives us 330 degrees. So my two answers for theta are 210 degrees and 330 degrees. Okay, now again, we could have said, okay, well, I want a 30-degree reference angle in quadrant 4. Well, how about negative 30 degrees? Okay, well, sure, that's true, okay, but that's why they said up here, they want their answers between 0 and 360 degrees. We don't want to have to deal with a bunch of coterminal angles. Okay? All right, so again, our answers are 210 degrees and 330 degrees because those give us 30-degree reference angles in quadrants 3 and 4, which is what we want. All right, let's take a look at the second example. All right, we got 6 times the cosine of theta plus 3 root 2 equals 0. Okay, so on this one, what do we want to get by itself? Well, we want to get cosine theta by itself. And then we got to evaluate and see, okay, what's our angle going to be? Okay, so first of all, we want to get cosine theta by itself. Let's start by subtracting 3 root 2 from both sides. And then I get 6 times the cosine of theta equals negative 3 root 2. Next, I want to divide by 6 to get cosine theta completely by itself. And then I get cosine theta equals, let's see, it's going to be negative in a fraction. This 6 and the 3 reduced to give me a 1 here and a 2 there, so we get a 2 on the bottom. And then 1 times root 2 is just root 2. Okay, so we get cosine theta equals negative root 2 over 2. Okay, so the cosine of what angle equals root 2 over 2. Okay, that's what we want to figure out. We also want to figure out where's cosine negative. Now, one thing we want to keep in mind, cosine of what angle equals root 2 over 2? Let's see. Cosine of 30 degrees would be root 3 over 2. Almost, not quite. Cosine of 60 degrees is 1 over 2. That's not it. And then the cosine of 45 degrees is 1 over root 2. So which one of these is root 2 over 2? Well, none of these three angles, right? None of them quite worked. But the thing that we got to remember is that root 2 over 2 is the same as, and it's negative, so I'm putting a negative, 1 over root 2. Because when we rationalize this by multiplying by root 2 over root 2, we would get this. I'm sorry. When we rationalize this, we would get this for an answer. Okay? So these two things are the same. So when it's asking the cosine of what angle equals this, that's the same as the cosine of what angle equals this. So then the cosine of what angle is 1 over root 2? Well, look at our special triangles, special right triangles again. And then where do we see a root 2? Well, in the 45, 45, 90. So then it's got to be there, right? Let's see, 45 degrees, cosine would be 1 over root 2. Yeah, that's what we're looking for. Okay, so now we know we have a 45-degree angle that we're dealing with. And then we also want to know, well, where is cosine negative? Okay, so let's see, cosine is positive in quadrants 1 and 4. So it's going to be negative in quadrants 2 and 3. Okay, so now we know that we want a 45-degree reference angle in quadrant 2 and a 45-degree reference angle in quadrant 3. Okay, so let's draw that. What's that going to look like? Okay, so a 45-degree reference angle in quadrant 2 is going to look something about like this. It's going to be right in the middle of quadrant 2. Okay, and then we can say we went 90 degrees and 45 degrees past that, or we can say 180 degrees minus 45 degrees. And then that's going to give us, no matter how we look at it, 135 degrees. So one answer for theta is 135 degrees. You're usually going to have two answers on these problems. Okay, and then what's my other answer for theta? Well, we know that having a 45-degree angle, reference angle, sorry, in quadrant 3 also works. So then how far would I have to rotate to get to here? Well, this one would be 180 degrees plus 45 degrees, which is 225 degrees. Okay, so then these are my two answers for theta. Okay, so again, first we want to get the trig function part by itself. Then I need to figure out two things. Which quadrants am I in? And that depends on if my answer is positive or negative. Okay, and then what's my reference angle going to be? And you're going to get that from your special right triangles. And then once we have all those pieces of information, we can figure out how far we got to rotate to get to those two places. All right, moving on. Second to last problem here. Okay, this one. 3 times tangent squared theta minus 1 equals 0. So this time I want to get tangent squared theta by itself. Now we do want to get the tangent of theta by itself. And then how do we get rid of something squared? How do we get rid of an exponent? Well, we square root. Okay, so just like any other algebra problem, we're going to solve by eventually using a square root here. But we're going to first start by adding 1 to both sides. So we get 3 times tangent squared theta equals 1. And then divide both sides by 3. And I get tangent squared theta equals 1 over 3. And then next, like we talked about, to get rid of the exponent, we want to take the square root of both sides. Okay, so then that gives me tangent theta equals, now don't forget, anytime we take the square root of both sides of an equation, what do we need to put? Plus or minus. And then I get the square root of 1/3, which is the same as the square root of 1 over the square root of 3. And the square root of 1 is 1 over the square root of 3. We'll leave that how it is. Okay? And then we don't need to rationalize this. This is fine. We just want to know what angle gives us this ratio. So don't worry about rationalizing that denominator. Okay? All right, so first of all, where does tangent come out, positive or negative? Well, if it can be positive or negative, that's all 4 quadrants. So then for this one, we're going to have 4 answers. And then the tangent of what angle is 1 over root 3? Okay, let's go check our special right triangles. Okay, so let's start with 30 degrees. Tangent would be 1 over root 3. Well, perfect. That's the one we're looking for. Okay, so now we know we're going to have a 30-degree reference angle in all 4 quadrants because it can be positive or negative. Sorry, positive or negative is what I was pointing to. All right, so then what's that going to look like? Well, I could have a 30-degree reference angle in quadrant 1, a 30-degree reference angle in quadrant 2, a 30-degree reference angle in quadrant 3, or a 30-degree reference angle in quadrant 4. Okay, and then how far do I have to rotate to get to those parts there? How far do I have to rotate to get to that first angle? Well, just 30 degrees. So that one's easy to figure out. So one answer for theta is 30 degrees. How far do I have to rotate to get to this angle? Well, all the way to here would be 180 degrees, and then minus 30 degrees gives me 150 degrees. So that's a second answer. How far do we have to rotate to get to this terminating ray? Well, that would be 180 degrees plus 30 degrees more, so that's 210 degrees. And finally, how far would I have to rotate to get all the way around to that terminating ray? Well, it'd be 360 minus 30 degrees, right, which would be 330 degrees. So then these are my 4 answers for theta for part C. Okay, so again, get the trig part by itself, figure out what quadrants you're in based off your signs, and then figure out what angle gives you this ratio. Once you have all that stuff, then you got to figure out how far you got to rotate to get to that reference angle in the given quadrants. All right, last one. Now, excuse me, on some of these problems in the past, we used to make you factor them or do a little more algebra to solve. I think they took all those away. Anything like this you're going to get already in factored form. So think of it this way. Somebody gave you some problem and then they factored it for you and they got these 2 factors. Okay, great. Well, now I've got this thing times this thing equals 0. Well, if I'm multiplying 2 things and my answer is 0, what has to be true? One of these things has to be 0, right? So then how do we figure out when each of these things equals 0? Well, set them equal to 0. So then I want to know, when does this thing equal 0? So then I got 2 times the cosine of theta minus 1 equals 0. That's one equation that I want to solve. And I also want to know, when does this thing equal 0? So when does tangent of theta plus 1 equal 0? Okay, so here they're kind of giving us 2 problems we have to solve all in one. Okay, and I just want to solve these individually and then get however many answers I get. All right, let's start with this one here. We'll do the cosine problem first. So I want to get cosine theta by itself. I want to start by adding 1 to both sides. And then we get 2 times the cosine of theta equals 1. And then next, divide both sides by 2. And we get cosine theta equals positive 1/2. Okay, great. Partly done. Next, what quadrants is cosine positive in? So then we want to look up at our cheat sheet here at this part of it, and where's cosine positive? Well, obviously in quadrant 4 and quadrant 1. Everything's positive in quadrant 1. Okay, so I know I'm going to have answers in quadrants 1 and 4. And then, well, next, what is my reference angle? The cosine of what angle equals 1/2? Okay, we'll go check your special right triangles. Excuse me. Is it 30 degrees? The cosine of 30 would be √3/2. Well, that's not what we're looking for. Cosine of 60 degrees would be 1/2. Yeah, that's what we want, 1/2. Okay, so then now we know we have a 60-degree reference angle in quadrants 1 and 4. So it's going to look maybe something about like this and about like this. Okay, how far do we have to rotate to get to here? Well, that's easy. That's just 60 degrees. So then one of our answers for theta is 60 degrees. How far do I have to rotate to get all the way around to here? Okay, now this would be a 60-degree reference angle. It'd be 360 degrees to get to here. So 360 minus 60 would give you 300 degrees. Okay, so then there's 2 of my answers. Next, I want to solve this equation up here and get most likely 2 more. Okay, all right, so this one, to get tangent theta by itself, we just need to subtract 1 from both sides. And then we get the tangent of some angle equals -1. Okay, all right, let's see. The tangent of what angle is -1? Well, where's tangent come out negative? Okay, so then look up here at our list again. Tangent is positive in 1 and 3, which means it's going to be negative in quadrants 2 and 4. So we know we're in quadrants 2 and 4. And then next, well, the tangent of what angle is 1? Okay, so let's see. Tangent of 30 degrees would be 1/√3. No, that's not it. Tangent of 60 degrees, √3/1. That's not it. Tangent of 45 degrees, 1/1. Yeah, that's what we're looking for. So then we have a 45-degree reference angle in quadrants 2 and 4. Okay. All right, so then let's draw that. So 45-degree reference angle in quadrant 2 would look something like this, and quadrant 4 would look something like this. Okay, so there's different ways to think about your answer, but how far do we have to rotate to get to here? Well, you can either do 90 plus 45 or 180 minus 45, but we get 135 degrees. And then how far do we have to rotate to get all the way around to here? So you can do, this is 270 degrees plus 45 degrees, or 360 degrees minus 45 degrees. Either way, we get 315 degrees. Okay, and then those are our 4 answers for part D. Okay. All right, so again, just a quick little recap. We'll just look at part B, for example. Okay, so to solve something like this, what do we want to isolate? Okay, there's not really a variable. I mean, there is theta, but we don't want to get theta by itself. We want to get the trig part by itself. So in this case, cosine theta. Once we get cosine theta by itself, I want to figure out, well, when does this trig function come out negative or positive or whatever it is? That's going to tell us which quadrants our answer is going to be in. And then next, we want to figure out, well, the cosine of what angle gives us this ratio, or in this case, it was this ratio. Okay, and then that'll tell us what our reference angle is going to be. And then we can draw it to get a visual and see how far do we have to rotate to get to those 2 terminating rays. And that's going to give us our 2 or maybe 4 answers. Okay, or sometimes it could be no solution as well. Okay, and don't forget, occasionally you can even land on your axis, so it could be a quadrantal as well. So you might see that come up. We'll probably do one of those together in class. All right, and that wraps up the Objective 4 notes.